I'm going to share this whiteboard so that we can discuss. Okay, it is not showing here. Something wrong. So come to the screen. Yes. So now see, this is the one question that I have given. Dy by dx. I have already given the answer. I think no. Dx equal to cos. This is among the question. X plus
Yes.
y plus 1. So its answer is x equal to cosec x plus y plus z, and then minus cot x plus y plus z. Z nahi, 1. There is no z. It should be 1 plus 1 and then plus 1 and then plus c. Fine, I remember. Question number 2 that I have given. Should I think this question also I have given x dy by dx. This will be equal to square root of 1 plus x square plus y square plus x square y square. Yeah.
Yes, sir.
Yes, sir.
Okay. So the answer is 1 plus x square to power 3 by 2 and then minus 3 1 plus y square equal to c. Then question number 3 I think.
Uh,
Yeah.
सर एक बार क्वेश्चन नंबर 2 करवा दो.
अच्छा, क्वेश्चन नंबर 2 करवा दें. ठीक है, करा देते हैं ना, डोंट वरी. और क्वेश्चन का आंसर लिखवाऊं?
हाँ जी.
Yes, sir.
Okay, so I think I have to bring it. The which questions I have given. So, wait. So I think these questions I've also given. Some more questions I've given. ओके, आप क्वेश्चन मुझे बताएंगे तो मैं आंसर बता दूंगा कि क्या क्वेश्चन और दिया था मैंने.
क्वेश्चन था x
Sub
क्यूब
bracket x cube plus x y square plus a square y फिर dx में मल्टीप्लाई प्लस y cube plus y x square minus a ब्रैकेट में फिर dy multiply is equal to 0.
Yes, I remember that question and it is a challenge for the differential equation. ये मुझे देखना था कि ये क्वेश्चन मैंने तो ये दिया है, ये क्वेश्चन करने के लिए आप लोगों को. और एक होमोजेनियस क्वेश्चन कल जो दिया था ना मैं शायद ही, this question I have given x cube minus 3xy square into dx equal to y cube minus 3x square y into dy.
यस सर, उसको इंटीग्रल पूरा सॉल्व नहीं हो रहा है.
It is a good question and this question is for practice. आप करिए इसको, बहुत ही अच्छा क्वेश्चन है. आप जितनी बार ट्राई करें and this gives you a learning. All right. At the end तो मुझे कराना ही है before the exam or before the test, but you should try because it's a good question. कुछ क्वेश्चन मैं ऐसा दिया है मैंने आपको ताकि आप लोग थोड़ा सा उसको ऐसे लेके चलें. So अभी होमोजीनियस से क्वेश्चन दिया था मैंने आपको शायद, x dy minus y dx equal to square root of x square plus y square. ये दिया था क्या क्वेश्चन?
Yes, sir.
ये आपने करके दिखा दिया.
Yes, sir.
x dy minus y dx equal to square root of x square
Yes,
plus
sir.
y
Yes,
square
sir.
dx. कर दिया आपने?
Yes, sir. Yes, sir.
यस सर.
तो ये dx था यहाँ पे. ओके, ठीक है. तो आपको मैं ये क्वेश्चन जो बता रहे हैं आप 2 इसको कर दें. हालांकि इजी क्वेश्चन है, मैं इसको देखिए कर देता हूँ, है ना. Okay, before going to start that one, today just make it an announcement. Today I will interact the 5 people. Yeah, everybody is there now in the class. Everybody 71 is there. Okay, fine.
Yes, sir.
So remember, I'm just calling the name. The 5 people I will interact after the class. Priyanshu Gupta is there. Rohan Khanna, Satyamitra Gupta, Warren Atre, and Rafiqul Haq. The 5 people you should be remain with me after the class. Priyanshu Gupta, Rohan Khanna, Satyamitra Gupta, Warren Atre, and Rafiqul Haq. Okay. Yeah, this is showing Rafiqul Haq Chaudhary. Okay, fine. So come to the this question. Question is there. But a simple question tha, like question number. That question is y upon x and then dy by dx. This is equal to square root of 1 plus x square plus y square plus x square y square, right? And this question can also be written, make it like that. This implies that can be written as square root of this this equation can be written like 1 plus x square into square root of 1 plus y square. Can we write it?
Yes, sir.
Y by x and then dy by dx. Then x into square root of 1 plus x square dx. This will be equal to y upon square root of 1 plus y square dy. Right?
Okay, sir. Got
I
it.
call it equation. I know.
Thank you, sir.
You can do that now.
Yes.
No issue. So simply you just take 1 plus x square, you solve it this side equal to t1 and 1 plus y square equal to t2 and then you solve it. You'll get the answer. Fine.
Yes, sir.
Okay, so you can do that. Otherwise, I will do. If you cannot, there is a simple way because more than 50% the hints I've given. So you can
No,
do
sir,
that.
I can do
You
now.
will do.
One
Okay.
more question you have also given.
Yeah.
X dy by dx equal to y in bracket log y minus log x plus 1.
Okay, 1 minute. Just I want to check the question. Based on homogeneous equation.
Yes, sir. The same doubt.
Okay, homogeneous form of the equation. I have given. Fine. Okay, that question is variable separable or that one? Homogeneous equation.
Homogeneous.
Okay, the question was okay, x dy by dx equal to y into log y minus log x plus 1. Yes, this one now.
Yes, sir.
So the simple one. So what's the problem there?
सर इसका आंसर log y by x equals to xc है.
Yeah,
Yes, sir.
100%. Log y by x equal to cx. This is the answer.
Okay, sir.
Fine.
Okay, sir.
So
I got
that
it.
one also 1 plus e to the power x by y dx plus e to the power x by y 1 minus x by dy.
Question number based on the homogeneous or non-homogeneous variable
Sir, x
separable.
equal to be the homogeneous.
No, that question you are asking me is based on homogeneous or non-homogeneous?
Sir, homogeneous.
Homogeneous base. Okay, what is the question?
So 1 plus e to the power x by y dx plus e to the power x by y 1 minus x by y dy.
Okay,
सर ये
okay.
आपने पिछली क्लास में दिया था.
ओके, पिछले क्लास में दिए थे. अपना नोट देखने दीजिए मुझे. क्वेश्चन कहाँ है? क्वेश्चन पूरा दिख जाएगा तभी करेंगे. Okay. This is based on homogeneous equation. So the question was, okay. Homogeneous form of differential equation.
वो पार्शियल मेथड में दिया था सर।
हाँ एक सेकंड मैं सब मैच कर लूँ, सारे क्वेश्चन सिस्टमेटिक वे में होना चाहिए। वन प्लस ई टू पावर एक्स, this is not the question I have. I don't have that question. Equation this y by 1 plus e to power x by y. Okay. E question based on E. There is no question on E.
सर
तो
आप
वेरिएबल
जब वेरिएबल सेपरेबल पढ़ा रहे थे तब आपने
हाँ।
ये वाला क्वेश्चन दिया था।
हाँ ये तो वही तो कह रहा हूँ, मैं पूछ रहा था इनसे कि होमोजीनियस का है या वेरिएबल
होमोजेनियस से
सेपरेबल।
पहले वाला सर।
तो मैं वही तो पूछ रहा हूँ, मैं होमोजीनियस के उसमें देख रहा हूँ क्वेश्चन बैंक में। That is not related
Question
to the
11.
homogeneous. 1 plus, okay. These are the questions. Y, sin Y, because I have so many questions based on homogeneous form, right? Yes. This is the question. I think it is given. The question is, देखिए आप लोग, it is again a good question. Question है 1 plus, I think 1 plus e to power x by y dx, and then plus, this is given in the question bank also, e to power x by y into 1 minus x by y dy equal to 0. Is it this question?
Yes, sir.
Yes.
Okay, so what is the problem
Yes.
there? We're not
I
solving.
just wanted to check the answer.
Okay, fine. What is the answer?
So e to the power x by y plus x by y multiplied by y equal to c.
100% answer. Yes, this question actually we have to make it first a variable separable, but it could not be make a variable separable. This is the question. It comes under the variable separable, but there should be must require this x by y is there. That means is a kind of homogeneous. It's not a homogeneous kind, but yes, it is a homogeneous equation, but it is studied in the variable separable form because. Somewhere it is required this variable separable form. So this question can be solved by using the x plus y, x by y equal to v ना, ये कैसे किया सॉल्व अपने, this can be solved by y equal to vx, right? So
Yes, sir.
right, मैं एक सिंपल
Sir,
फॉर्म में लिख देता हूँ इसको, जिन्होंने सॉल्व नहीं किया, those who have not solved, just I'm writing at a certain step. You can write it 1 plus e to power x by y. Suppose anyone who was not able to solve this question, dx. Now this is the question. Actually, this is the question. So this can be written as take a common of this one. So e to power x upon y, then into 1 minus this x by, this is x by y, and then plus this, you can write it e to power x by y 1 plus, then this is 1 plus e to power x by y, right, this one, and I should make it dy by dx here, dy by dx, and this will be dx by dy, because this term is written there this side, so this should be dx by dy. This is dx by dy. All right, dx by dy equal to 0. So I am writing this equation as 1 here. Now this is the rearrangement of the question, and now you can put y equal to vx. So here you can get you can in place of x by y, in place of x by y, because here dx by dy is there, so we can change it. x equal to vy also, right? So this implies that dx upon dy, you can get it here, and this will be equal to v plus y dv by dy. All right, now put it in one, so this will make a more simple form. So actually this is the part of the homogeneous equation, but actually this is the part of homogeneous equation, but we are not doing what actually we are doing. Y equal to bx is there, we have to replacing uh, in this equation. There is no mention, it is not mentioned that y is the independent variable. So in homogeneous we are mentioning y has to be changed into the v form, but here it required x has to be changed. X has to be changed in the v form. In this equation x has to be changed in the v, this is the independent variable. So when you put this equation, it will be changed into the variable separable form, and then apply variable separable form. Make it sense, everybody? Separable form and solve. So the answer is, I think this is your answer. The answer is x upon y and then plus e to power x by y and then into y equal to c. This is the answer now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Good. Should I move to the next topic?
Yes, sir.
Sir, I have to ask a question.
Yeah.
Sir, x cube plus xy square plus a square y का whole dx plus y cube plus yx square minus a square x का whole dy is equals to 0. Sir, I was not able to solve it.
You are not able to solve this question, eh?
No.
Okay. Again, this is the question based for the homogeneous form of differential equation, right? So I am writing this question. So I am going to solve this question, right? Okay. This is the question that I have given. I think just to read the question, x cube. Yeah, please read the question. X cube plus
xy square
plus
a square y whole dx
okay dx
plus y cube plus yx square
okay
minus a square x whole dy is equals to 0.
dy equal to 0. Correct. No issue. So this is a good question that I have mentioned it, that this is a good question and we ask in many times in the exam at university level. So how to write this question? Now see, solution, we can just rearrange. Take the common here at this side. So I'm taking the x common here. Because there are so many methods are there. When you go for the exact method, when you go for the non-exact method, and some other methods is also, and this question can
There's
also
an
be solved by,
integrating factor.
yes, integrating factor. When you multiply with the integrating factor,
Yes,
who
sir.
said? Who said?
Sir Ayush.
Ayush, good, Ayush. So the integrating factor is one of the factor or the expression of x and y. When you multiply the equation, it will be integrable, right? Integrating factor means the equation can be integrable and can have the solution of the differential equation. All right. So here this is before going to the ith method, exact method or non-exact method are there, that this question can also be solved by that method, right? So at that time we will solve this question by that method also. So now presently we are here for the present method we are discussing. We'll solve this question by this method, right? So I said in the last class that the differential equation can be solved more than one method if it satisfy the condition of the particular method. So we can write it x into x square plus y square into dx and then plus a square y dx. Can we write it? Then plus, I'm taking y as a common here, y square plus x square dy and then minus a square x dy equal to 0. All right. So I call it this equation 1. Equation 1. So now see what the things are coming in your mind. What the things are coming in your mind. That this x square plus y square is there, though why should we not divide by? So divide both sides. Dividing by x square plus y square, right? So suppose when I divide this equation, this will be x dx plus y dy, and then this from this part, x dx plus y dy, and then plus combining this equation, this will be a square into y dx minus x dy, and then divide by x square plus y square equal to 0. Yeah, who asked this question? Yeah.
Sir, me Kadam Tripathi.
Kadam Tripathi, good. So this is a good question, Kadam. This is a good question, and this question again will meet after some class, because so now see, you know what is this value, this one, y dx minus x dy upon x square plus y square. There is some shortcut method that this will be integrable, right? So I will provide when you go for the exact form. Yes, direct differentiable. No, we have a differentiable form of that, directly differentiation of particular value of or that. Now that is another way. I will give you the formula of that shortcut method. That is particularly I have the method that directly we can make it into integrable form, and then we can integrate it. But here I'm dividing the numerator and denominator by the last term of y square. So I'm taking this, just I'm dividing by y square, right? So last term ko I'm just dividing by y square, because keeping other term same and dividing it by this equation. So x dx plus y dy, and keeping it like plus a square, and when you divide it by y square, so this will be 1 by y dx, then minus x by y square dy, and then divide by 1 plus x square upon y square, and this will be the separate term, and this will be equal to 0. And then further we can write it. If you go for the exact form, this will be very simple, but okay, no issue. This is x dx plus y dy, and then plus a square. Now see, 1 by y dx minus x by y square dy, this will be what? When you differentiate with respect to this x by y, you will get the numerator term, right? Upon 1 plus x upon y ka whole square. Is it okay? So dx by dy, this will be equal to 1 by y dx minus x by y square dy. This is nothing but dx by y. This we can write it dx by y. Fine. Make it sense or no?
Yes, sir.
Yes, sir.
Okay, no issue. I will give you the more specific thing that not make it so. That the formula. Okay, I'm giving the formula. That formula I have. There is that one. The formula is 10.1. Okay, I have the formula okay, fine. Yes, integrating factor. Just I'm giving you the shortcut of the formula that can be written like this. So see, this will be how to write it. I'm writing one or two formula so that it will make it clear how it will be like that, right? So this is I'm writing a d y dx minus x dy upon y square. So this will be equal to d of x by y, right? Suppose this is I'm writing here y dx minus x dy upon y is x square. This will be equal to d of minus y by x, minus y by x. Directly we can write it. Similarly, if we have the formula y dx plus x dy, this will be directly written as d of x and y, x into y. So rather than you cannot integrate like this, you cannot integrate here, but you can integrate it like that. Fine, because directly you get the integration and differentiation will inverse to each other, and you'll get the xy here. Getting my point? Yeah, Kadam Tripathi.
Yes, sir.
Are you getting this point?
Sir, I think it is exact differential of tan inverse y by x.
Yeah. I will give you a list of the formula. I have so many formula, but this formula will give you when I will teach you the exact formula, right? Before that, it makes a confusion to you. Dx plus
Yes.
minus, suppose dy dy. So here you cannot this directly you can write it uh, this is d of x square plus minus y square. So this is the combined formula, and this is the exact form of differential equation. These are the exact form of differential equation. So like that, I'm using this same concept here. So this makes like this equation is as per the formula, and then this can be written. So I'm making this equation 2. So now put x by y, because I'm using the variable separable form. That's why I should make it as variable and separable form, otherwise no issue. The x by y equal to t. So this implies that x dx plus y. So the equation becomes, from 2 we can write it from 2 x dx plus y dy, and then plus a square, and this will be what, dx by y means dt. This is nothing but I just put x by y equal to 2t. This is the dt, and divide by 1 plus t square, and then this is equal to 0. Fine. Now see, is it integrable now? This is equation 3, integrating.
Yes, sir.
Integrating now, because it is already variable separable form. X is with x dx, y is dy, and dt is with a t. So when you integrate it, integrating of x dx, and then plus y integration y dy, and then plus a square integration dt upon 1 plus t square equal to 0. So this gives you the c value, right? Not c0. This gives you the c value. So this is nothing but x square by 2 plus y square by 2 plus a square. What is the value of this? 1 by t square. This is
Tan inverse
tan
It's a
inverse
tan
t
inverse.
square.
Tan inverse T.
equal to c, or simply that x square by 2 and then plus y square by 2 plus a square. This is uh, a square, or we can write like that. I'm just solving using this 2. Why should I write here? Make it x square plus y square. This implies that plus 2 into a square, and then tan inverse, and t we replace it by x by y, and then equal to c. Make it sense? आया समझ में सबको?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So Kadam, thank you very much for asking a good question. Now I think I should move to the next topic. Yes.
Yes, sir.
Yes.
So now come to the non-homogeneous form of the differential equation. All right. So moving to the next topic. Yeah, everybody is with me now.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Fine,
Yes,
fine.
sir.
Okay. Just I want to see, because everybody must be active in my class. Don't use WhatsApp or anything else, because randomly I can ask the question to anybody, and if you are not able to give the answer, or you are not responding, that means you are using that apps or something like that, and you are not actually in the class. So it might be possible that I'll mark absent. 3 call, if you will not give the response, that means you are busy somewhere. So Vaibhav Dubey is there in the class. Vaibhav Dubey. Vaibhav Dubey
Sir.
is in the class.
Yes, sir.
Okay, so what I taught is just before 1 minute or 2 minutes. Yeah, Vaibhav, please respond what I taught.
Actually, sir, my network is very slow.
Uh, so what happened?
Sir, I am
Yeah, yeah. Tell me, I'm listening. Okay, Urvi Dashmana. Urvi is
Yes,
there in
sir.
the class? Yeah,
Yes,
Urvi.
sir.
What I taught beta in the last class, just before 1 minute.
Um, Sir, basically solving questions.
What was the question?
So the question,
Yes. What was the question? You wasn't in the class, na?
I am in the class.
Okay, so what is the problem? The question I have already solved. A good question that I have solved. A good question, a very good question. Yeah, Urvi. Okay, we should take care and be serious in the class, right? No issue. In the next class, I will ask some more question. Come to the new topic. Come to the new topic. Okay. So I have covered the variable separable form, first method. Second method, the homogeneous form of differential equation that has to be transformed or reduced into the variable separable form, and then we can solve it. Now the third method, and this is called the equation non-homogeneous form of differential equation, or we call it equation reducible to reducible to homogeneous form of differential equation. Reducible to homogeneous form of differential equation. Homogeneous form of differential equation. All right. So this is what generally we are saying, that yeah, it is a non-homogeneous form of differential equation. Non-homogeneous form of differential equation. But why I'm written here that reducible to homogeneous? Because some homogeneous equation cannot be reduced into the non-homogeneous cannot be reduced into the homogeneous form. That's why I'm writing the equations which can be reduced into the homogeneous form. Then we can solve it by differential equation. So non-homogeneous means what is the chain of this? Because if it is a non-homogeneous, if it is non-homogeneous equation, homogeneous differential equation. So the way is that we have to convert it into the homogeneous form, homogeneous differential equation, and then we reduce into the variable separable form, separable form, separable form, and solve form, and then solve that question. Is it okay now? So this is the chain that we can will follow here in the this non-homogeneous differential equation. But the question is that how, when you call that this is non-homogeneous, and what is the way that we can solve this non-homogeneous differential equation? There are some special cases also. So I'm writing here the equation, the way, the methodology that we can solve the non-homogeneous differential equation. So the equation or we call it differential equation of the form, we call it differential equation of the form dy by dx, this is equal to ax plus by plus c, small c, then divide by capital Ax plus capital by and then plus capital C, where small a, b, c, capital A, capital B and capital C are constant. Fine. So this is the equation can be made homogeneous form, can be made in homogeneous form by putting, simply we have to putting this small x equal to capital X plus h, and small y this is equal to capital Y plus k, where k and h and k, where h and k are constant again, right? Constant again. So when you differentiate it, this will be equal to dx equal to d of capital X, and here when you differentiate dy, this will be equal to d of capital Y, right? So we have to determine constant. So we determine this dy by dx, and this will be nothing but this will be equal to dy upon dx capital X. We have to find it, right? So from equation 1, I'm using this equation 1. I will explain again, don't worry. Unless and until I will not move, unless and until you will not the methods or the concept are not clear, I will not move. So we get here, from 1, we call it from 1, d capital Y upon d capital X. So when you're replacing x by a small capital X plus h and y by capital Y, when you put this value here, that means when you are replacing this x by capital X plus h and y by capital Y plus k, and when you multiply ax, this is ah, by and bk, a, b, c, h, and k are constant. So this equation reduced to, this will be reduced to ax plus by capital Y and then plus small a into h plus b into k plus small c, and then divide by this whole equation ax then plus by then plus ah capital A into small h plus by and then plus, sorry, by b bk and then plus capital C. Now see, this is equation 2. Now we have to choose now.
सर ये वाला स्टेप में आपने कौन सी वैल्यू कहाँ सब्स्टिट्यूट करी, एक बार दोबारा बता दो।
जहाँ x है इक्वेशन 1 में, जहाँ x है वहाँ that is capital X plus h, and where a small y, in place of a small y we have to put the capital Y plus k. This is the substitution. I will explain. I am going to again to the first step to the last step. I will repeat it. So this is the dy by dx. Now see, everybody has to concentrate on the equation number 2, right? Equation 2 can be homogeneous if, what is the condition? This equation will be homogeneous.
सर
Yeah.
सर आपने जो सेकंड इक्वेशन लिखी है उसमें
हाँ।
जो डिनोमिनेटर है उसमें एच प्लस बी के प्लस सी क्यों आ रहा है ब्रैकेट में, क्योंकि वहां पे तो हम सब्स्टिट्यूट कर नहीं रहे हैं।
सब्स्टिट्यूट नहीं कर रहे हैं, अच्छा ठीक है।
नहीं कर रहे हैं सॉरी कर रहे हैं।
आ जाएगा ना, सारे कांस्टेंट एक तरफ आ जाएगा बेटा, सारे कांस्टेंट एक तरफ आ जाएंगे और इनके फिर x और y के कोएफिशिएंट बन जाएगा। अब माय क्वेश्चन इज दैट दिस इक्वेशन रिड्यूस टू homogeneous form, homogeneous equation, but the question is how?
सर जब उसका जो कांस्टेंट वाला पार्ट है वो 0 हो
कांस्टेंट वाला पार्ट जो है वो 0
yes, अगर ये 0 हो जाए और ये वाला ना एक्सप्रेशन 0 हो जाए,
हाँ,
तो
जीरो हो जाता है बोलेगा।
that means this become the homogeneous form. Yes.
Yes, sir.
Yes,
Yes,
sir.
sir.
Good. Good. So now H and K are chosen, are chosen, are chosen such that this AH plus BK plus C equal to 0 and AH plus BK plus C equal to 0. So we have to solve this equation to this linear differential equation in terms of H and K. So linear equation, system of equation in terms of H and K. मैं इसको और clear कर देता हूँ. H, so that we can find the value of H and K here, right? We can get it. So equation 2 can be reduced. If it will be equal to 0, then equation 2 can be reduced to dy upon dx. This is equal to a capital X plus b capital Y upon a capital X plus b capital Y, and this is equation number 3 is homogeneous form of differential equation, and can be solved by putting capital Y equal to V capital X, and then make it, मैं सारी चीजें लिख देता हूँ, बुक में कहीं नहीं लिखा रहता है. Then transform to variable reducible form to variable separable form and solve. That's all. अब मैं शुरू से आपको स्टार्टिंग से बताता हूँ, है ना, बिल्कुल शुरू से. बहुत सिंपल है, very simple. Everybody, I'm using sometime the Hindi word, but I think maybe somebody is not comfortable in Hindi, so try to discuss in English. So this is the equation 1 here. Fine. Come to the step 1. So I'm coming to the first step here. That is the equation which is reducible to homogeneous form. That means the equation is non-homogeneous. Fine. So if it is non-homogeneous equation, the way is what you have to convert this equation into the into the homogeneous form, and then this homogeneous form again using the another variable v, say y capital Y equal to vx, and replacing one independent variable with another independent variable. Say what I did in the previous class, that y has to be replaced by the another independent variable v. So same way we can apply here, this y replaced to v. So homogeneous equation has to change into the this variable separable form, and then you can solve the equation, you will get the answer. Fine. It's very simple. Very simple, right? Very simple, and you can get the answer. Fine. Okay. So just I'm saying that one of the equation. This is writing here as an introduction of the methodology introduction. Right. Now see, this is the dy by dx equal to ax plus by plus c small c upon capital X plus capital B in small y plus capital C. This is the equation. This is in the form of that equation. Sometimes if this equation is there, maybe you will try to find the variable separate, but directly you cannot find, because x and y is there, and this is not the, this is the implicit function. You cannot represent x in terms of y or y in terms of x, and this is the way that it is looking like that. So directly the question form of the question, it will show that yes, it is a non-homogeneous equation, right? And again, now see, the why it is non-homogeneous, because at the above at the numerator expression, the degree is not same, because your x is power 1, y is 1, and there is no, here is 0. Again, denominator, every term is not have the variable x or y, or there is no degrees 1, 1 and 0. So this is not the homogeneous form of differential equation.
Hello.
Fine. Yeah.
Sir, your feed is freeze, sir. Your whiteboard is freeze.
Yes, sir. This
Whiteboard
is
is
freezed. Freezed.
No, sir.
whiteboard is freeze.
Yes,
Okay.
sir. It is freezed.
Your screen is freezed.
Okay. Okay. No issue. Okay. I'm going to whiteboard is freeze. Where is this? Is it okay now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Right?
sir. It was okay before only.
Yes, sir.
Okay. So this is the equation. This is the equation number 1. This is the differential equation, and this is not homogeneous. So the way is what users just put x equal to capital X plus y and small y equal to capital Y plus k. Small x is capital X plus h and small y equal to capital Y plus k. So when you put this value here in equation 1, the equation 1 will reduce into the form of equation 2. This is dy capital Y upon dx equal to this form. Now equation 2 will be homogeneous if these constant terms will be 0. So making this equal to 0, that means we have to find the value of h and k. So at that value of h and k, this expression of the constant equation h and k form, this will be reduced to the 0. So for choosing the value of h and k, it makes a 0. We have to put the value of h and k so that the value, this equation will be 0. So for that we have a two system of equation. This is system of equation is there. You solve it, you will get the value of h and k. Later on it required to put this value again. Then when you put this value right side of this equation expression, this is 0, you get the value of h and k, and the equation 2 will reduce into the equation 3. Right now equation 3 is in the homogeneous form because x degree 1, y degree 1, x degree. Yeah, equation 3 is in the homogeneous form. Fine. So this is homogeneous the same way to solve the differential equation of homogeneous form. Here the only difference is what, in place of small x, this is small y, small x. In place of capital there is capital X is there. In place of small y, capital Y is there. Small x, capital X is there. So you have to, this equation is in terms of capital X and capital Y. So you replace y by Vx, and this will reduce into the variable separable form, and then you apply the solution. So I'm going to stop here at this point of time because there are some special cases. So in the next class we'll discuss some special cases, and then we'll solve the problem. Fine.
Yes, sir. Thank you.
Should I stop here? Yes.
Okay.
Yes, sir.
Okay. 1 minute.
Yes, sir.
Download the attendance. Okay. So I said only the 5 people should be in the class. So thank you very much, and only the 5 people should be in the class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Sir, can you
Thank
please
you, sir.
repeat the name of the 5 people? I had a network issue, so I couldn't listen properly.
Who is speaking?
Sir, Rohan Khanna, sir.
Okay, Rohan. Okay, Rohan, no issue. Priyanshu Gupta, Rohan Khanna, Satya Mitra, Viren, and Rafiqul Haq, right? I take only 1 to 2 minutes so that we should make a discussion what actually is going there.